And we're going to start talking about C chart. C chart is used for attribute data SPC that's assessing the quality based on the defects and with the conditions of the sampling size of inspection is consistent throughout every single subgroups. So what does it mean by defects? If you can remember, you still can remember, is the difference between defective item and defect is defects is assessing the defective items per unit. Okay, so the example that we discussed in the first video of attribute control charts, I use example plastic parts. And this slide gives you another example. Inspector collects 5 beach towel. Oh, the example is towel. So the unit here is per towel, per towel. So the inspection is carried out to inspect the defective item per towels. And they record the total number of defects of the entire subgroup. So collected 5 towels and inspecting, doing the inspections to detect what are the defects that found in these 5 in the towels. So the defective item could be example till pool. Okay, all right. So that is the scenario that, and the example we discussed in our first video attribute SPT chart. I use example of plastic parts with a defect that called sink mark. Okay, uneven mark on the surface. The surface is sink and then cause a mark on the surface. So you pick a plastic piece, try to inspect. Is there any sink mark? It could be 0. It could be infinity. We don't know, right? So how many defects per part? So if that's the case, then we're going to use either U chart or C chart. And if the inspection is carried out by using a consistent sampling size, then we should use C chart. And this is what I'm going to discuss this slide. So I have a concern that perhaps some of you still don't understand in what, or still don't have a clear idea in what scenario you should use C chart. So I'll give an example, another example in this slide. So C chart is used when the sample size is consistent. Is there any other sentence that I not yet discussed? A unit of product, we're expecting best unit of products. Okay, so example. Okay, before looking at example, the objective. Objective for attribute control chart is very standard. You're using attribute control chart in order for you to identify or work out the process capability. The process capability for attribute chart is equal to the center line or control chart when the chart is statically under control or is what happened to this? Statically under control. Okay. So, and objective of the control chart, not only for C chart, applicable for NP chart, P chart, X by R chart, is for the management team to monitor the changes on the process and identify the assignable cost. And this is going to carry out continuously to improve the quality of the product or process. Okay. For those that still unsure or still have doubts on what does it mean by attribute data with defects. This is the example. Printed circuit box. Okay, example here is a printed circuit box. So in what scenario that I'm going to use U chart? I'm going to use U chart when, example, my company is producing printed circuit box and the inspection plan that I use in my company is The inspector will go to the PCB assembly line every time, pick up one sample PCB, consistently picking one sample of PCB. And then, as you might aware on the PCB, there are many electronic chips, there are many printed circuits. So the inspector is going to check every single components that uh, fixed or soldered into the PCB. It could be a resistor, it could be a capacitor, okay, it could be IC chipset. Inspecting, example, soldering problem or the part not aligned properly. Okay, so the first thing that the first criteria is the sample size must be consistent. Every time my inspector is picking one sample. And the first sample that picked, example, detected, oh, there are two defects. There are two defects. Not defective item, there are two defects. Example, this is soldering uneven, IC alignment out. Okay, so C stands for the defect. C equal to 2, or C is the defect. MP is a defective item, is a defect. And how about the second subgroup? Means inspector going at the morning shift, pick one. My inspector go to the PCB assembly line in the morning, pick up one piece of PCB, inspect, and the piece that he pick up, he found two defects in the piece of PCB that he pick up. In the afternoon, after lunch, then he went to the production of PCB assembly line, pick up another piece, consistently pick up the same number of sample, and inspect. And this round, there are 4 defects. 4 defects. Okay, so in total per day, there are 2 subgroups. Why 2? 2 inspection, 2 subgroup, and the sample size for each subgroup is 1. And the defect item for subgroup 1 is 2, the defect item for subgroup 2 is 4. Okay, so that is the scenario that is the conditions, that is the setting that you should use C-chart. Okay, so if that's the case, then the next thing is you need to calculate need to develop the center line and the control limit. The formula for center line, upper control limit, and lower control limit for C-chart is very straightforward. You're not required to know the subgroup size. You're not required to know size. What you need to know is only you need to know. Sorry, you don't need to know the sample size per subgroup. You don't need to know the sample size per subgroup. What you need to know is the total number of subgroup G, and also the count of non-conformity, the defects. You see, there are many terminology, like this is defect, or we call count of non-conformity, counting how many conformity. So in that example earlier on, and counting, there are 2 defect or 2 non-conformity. And then the second PCB, there are 4 non-conformity. So as far as you know these 2 numbers, then you can calculate the center line. Okay, you total up the count of non-conformity, you total up. Example, in my case earlier on, I have 2 defects in my first inspections and second defect in my second inspection. So the sum of my defects is equal to 6, 2 plus 4. And then subsequently, total number of subgroup. So in my case, my total number of subgroup is 2, because I only inspecting twice per day. Okay, so as far as you know this 2, then you can calculate the rest. So the center line of C bar, the average count of non-conformity, is equal to the sum of non-conformity divided by the total number of subgroup. And upper control limit is equal to C bar plus 3 square root of C bar. And then lower control limit is C bar, the average of count of non-conformity minus 3 square root of C bar. Done. Very straightforward. Example. You see example. In this example, you see why I'm using C chart is because I'm expecting a process and I'm counting the non-conforming, a C. I can, in this example, I put C, where I can put the counts of non-conforming. Okay, this what, yeah, the count of non-conformity, the non-conformity. So how to start with? You need to start with calculating the center line of C bar. So C bar is equal to the total of the count of non-conformity divided by the total number of subgroup. The total number of subgroup has 25. How about the total number of non-conformity? You have to total up the number in the third column here. So if total up, you will get a number of 138. 138. Then by knowing that the center line C bar is equal to 138 divided by 25. Then that is the center line of the center line of the C chart. And upper control limit is equal to 5.52 plus 3 times square root of 5.52, 12.57. And this is 0. Okay, maybe not in this slide, I think. Maybe yes, okay. You see, we are doing, what is C? C is the number, like we are counting the numbers of non-conformity. So normally in industry, we are practicing if the upper control limit is 12.57, we will round out to 12, not 13, because this is upper control limit. So why I round to 12? You see, there are two possibilities. I can round out to 13. Okay, upper control limit. I can round out to 12. Okay. So example, if definitely number of defective with number of non-conformity will not be in decimal point. Just example, if I take samples of 3 and when I calculate my C, because average, okay, then I got 12.65. Okay, 12.65. 12.65 if refer to the actual upper control limit is over. I should reset. However, if I round out 12.57 to 13, I will not reset. I will not reset a C of 12.65. Therefore, I need to set my upper control limit round to the lower side. Okay, and lower control limit is equal to 0. Okay, then that's it. You have the upper control limit, lower control limit, and the next you can just follow the practice or the step that you learn in P chart, NP chart, X bar chart, R chart to plot and find any point that out control limit. If there is, example in this case, how many points? Don't tell me that you have 5 points. No? You only have 3 points. These 2 points is even is on the lower control limit, but it's a good size. It's a point that you can use to study the best practice. So we're only interested to find out the root cause for point that's beyond upper control limits. Bear in mind, point that's on lower control limit, no action required, is only applicable for attribute control chart. And what you need to do for this three, as per usual, using your quality 7 to investigate the assignable cost and then remove the assignable cost. Once that is done, you can't just remove, now you have to investigate. So investigate and make sure that you found the root cause. Then you can remove this 3 point and revise the upper control limits. So normally come to revise, most of the book use a symbol of or or CO. I'm not very particular on this. You can use C also, no problem. So how to calculate a revised control limits? You just remove the point out the spec out the control specs from the original C, original G. What that mean? Okay, the original C is 138, and the original C bar is 5.52. When we take into consideration all the subgroups. Okay, so since there are 3 pointed out control limits, which is point number 5, subgroup number 5, 11, and 23. So the total number of non-conformity, 138, you need to minus out with the number of non-conformity from subgroup number 5, which is 20, 11, 14, and 23, which is also 14. So you have to minus out. And since there are 3 subgroups there are 3 data that took out from the total number of non-conformity, the subgroup size also need to be reduced by 3, and you will get the new revised control limits center line. And then by using the revised center line, you can count the so-called the control limits. So you can see here 10.16, you make it to 10. Okay. And continue doing that until the process is stable. Then when the process is stable, the center line representing the process capability for this particular process. Okay, that is all for feature. That's why I tell you very quick feature. And this is the exercise or tutorial for feature.